In a previous video, we found out how to find the maximum and minimum values of a square wave input, a unipolar square wave input to an RC low pass circuit. We are actually measuring the voltage across the capacitor, hence we are calling it a low pass circuit. Now, in the RC circuit, so we get a similar response like this. We get a response like this, and we were supposed to find Vmax and Vmin, and to find out like how how we did that, you can refer to that video. Now in this video, we will actually continue upon the results that we have got from the previous solution. Now we have some very interesting observations to be made. Now in while solving the question, while solving for Vmax and Vmin, we assumed the duty ratio to be 50%, and also we took the on time and off time, that is the T1 and T2 are equal, which is further equal to one time constant. Okay, this was just to make the calculations simple. Now uh, if we take, irrespective of what the on time and off time was, if the duty ratio is 50%, the maximum and minimum voltage will add up to A. Okay, so V max plus V min will be equals to the supply voltage A, the step voltage A, if the duty ratio is 50%, because it is intuitive. Okay, it will take the same time for charging as the same time for discharging, and hence the Vmax and Vmin will be equal, will equate to A. And the next observation we can make is, if D is approaching to 1, okay, if the duty cycle approaches to 1, which means the on time of the circuit is very like much greater than the off time, it will like have a negligible time to discharge, and it will act like a step input. So we have approximately a step input with minor undulations like this. Okay, so we have approximately a step voltage, and when the duty cycle approaches 0, it is something like a 0 voltage. So this type of thing is actually used in DC choppers. Okay, to regulate the voltage by varying the duty cycle of the step input, we can vary the capacitor voltage, the voltage across the capacitor. This is a very important concept which you will learn in choppers, which is from the subject of power electronics. The next observation that we can make is, if we increase the frequency, okay, if we increase the frequency at very high frequencies, the capacitor will see, inherently a capacitor allows low frequencies. Okay, so in it allows high frequencies and blocks low frequencies, that is, it blocks DC and allows AC, blocks DC and allows AC. Now if the frequency is very high, it will eventually act like a short circuit to those high frequencies, high input frequencies, and the voltage across it will be very much negligible. So for high frequencies, let me write here. Okay, what actually is the capacitance formula? 1 upon omega C. Okay, so if the frequency is very high, the impedance offered is very low, so the voltage drop across the capacitor, okay, across the capacitor will be negligible. So the output voltage, because we are measuring the output voltage, it will be, the output voltage will tend to 0 as the frequency tends to infinity. And if the frequency tends to 0, like for very low frequencies, it essentially means DC, the voltage V naught will tend to be its maximum value, which in this case will be A. So this maximum and this maximum is not the same, mind you. Okay, so the maximum voltage which a capacitor can reach is A, because the step voltage is A. Okay, now another very important thing which we can make uh, make out from this is, okay, uh, the output V naught average, the average output voltage, if we calculate, okay, how do we calculate the average output voltage? Okay, first we take the area, we can divide the area into three parts: A1, A2 and A3. A1 consists of this area, A2 is only this rectangular area, and A3 is this whole area under this exponentially decreasing curve. Okay, so after doing some mathematical mathematical formulas, okay, applying integration and all that, we can easily find A1, A2 and A3. And how do we find the average voltage? Add all those by the total time. The time taken is T1 plus T2. So after doing that, you will get this voltage. So what is the output voltage? It is the voltage across capacitor. Okay, because we are measuring the voltage across the capacitor, the output voltage is the voltage across capacitor, and this is the voltage across capacitor irrespective of the time period. On time, off time, we don't care. Okay, this is the generalized equation. Okay, and for that, to find the generalized equation, you first have to solve the previous problem. We have to find Vmax and Vmin. This is Vmin, Vmax and Vmin. The expressions have to be in, the equations are to be made in considering different the duty cycle to be different. Okay, not equals to 50, and also we took as the T1 and T2 to be tau. Okay, so you don't have to follow that method. It will be actually bit lengthy. It will be simple, but it will be bit lengthy, so I have not included it in. If possible, I'll give a link to the solved problem, okay, in the description. So yeah, so after finding out, we will find the average voltage across capacitor as this, and by after seeing this, you can easily make one thing out. Okay, this is also the average voltage of input of the input. Okay, so the input is on for time t1, which is A, and off for time t2, so the average voltage will be A times t1 by t1 plus t2. Simple. So we can see that in a RC circuit, the average, what is average? What do you mean by average? Average means the DC component. Okay, the DC component of the voltage, input voltage source, is directly appearing across the capacitor. And doesn't this sound similar? If you apply a DC voltage across a capacitor, an RC circuit, what do we get? The whole DC, eventually the capacitor will fully charge, and this DC voltage V will appear across the capacitor V, or the capacitor C. Okay, so the same thing is happening. So we can make a one generalized statement. If we have any type of source, the average voltage of that source, will be equals to average voltage across the capacitor for a simple RC network. Okay, for this network it is like that. Why? Because capacitor is known to block DC, so the DC component of the source will be blocked and will appear across the voltage, the average voltage across the capacitor. Simple. Okay, and this part, the input voltage, average voltage, this is the average voltage. This part is also known as the duty cycle. So varying the duty cycle, you can also vary the average voltage across capacitor. Okay, and also one important thing. Okay, average means DC. Okay, that is clear. If we apply a square wave, if you have studied Fourier series somewhere, okay, Fourier series actually decomposes this square wave into a bunch of sine waves. Okay, sine waves of different frequencies. So because also you might have studied Gibbs phenomena and all other things, so it relates to that. So you have this square wave contains thousands and thousands of frequencies, from the fundamental frequencies to the harmonics and all that. Okay, so what do you know about an RC circuit? The name itself tells you it is a low pass circuit. What does a low pass circuit mean? It allows low frequencies and blocks high frequencies. High frequencies. Yes. Yeah. Okay. It is a low pass circuit. So what can we like infer from that? Okay. Uh, okay. Let's see here. Okay. We got this waveform. Okay. We got this waveform. It was actually supposed to charge like this. Okay. But we got this waveform. Why do we get this waveform? Because in low frequencies, the voltage or all sine wave components in the lower frequencies are not getting attenuated. They are in their like the attenuation is not that much. But once the frequencies are getting higher, the attenuation is keeping on increasing. Hence, the the voltage component of higher frequencies keeps on attenuating, and we get a low the average voltage starts to decrease, and the attenuation is constant 20 dB per decade. Hence we get this type of waveform. Because it is a low pass circuit, we get this type of waveform. Okay, so I hope you got some very good insights about RC circuit and a different way of analyzing circuits, and thank you.